Hello viewers, today we will discuss about the fundamentals of a microprocessor. You all might go through this term microprocessor in your day to day life. So, let us start with the basic definition of microprocessor. It is a multi-purpose, programmable, clock driven, register based electronic device. It reads the binary instructions from memory. It accepts the data from memory. It finally processes the data according to instructions and then provides the result. There are varieties of microprocessor available today. Some of them are 8-bit, some of them are 16-bit and many more. So, now let us see the definition. Microprocessor is a multi-purpose, programmable, clock driven, register based electronic device that reads the binary instructions from memory. It accepts the data from memory. Finally, it processes the data according to instructions and provides the output. Microprocessor works on hexadecimal number systems. The different types of microprocessor with word size are 8085 a 8-bit microprocessor, 8086 a 16-bit microprocessor, etc. For any microprocessor, the main building blocks are its ALU, that is arithmetic and logical unit, then a CU, that is a control unit, and the registers. Now, let us discuss these three terms ALU, CU and registers. As the name suggests, ALU is responsible for performing the various arithmetic and logical operations within the microprocessor. The various arithmetic and logical operations are addition, subtraction, ANDing, ORing, XORing, complementing, rotating and some more. Now, you all might be familiar with these operations. Addition and subtraction are the basic arithmetic operations, while ANDing, ORing, XORing, complement, rotation are the logical operations. Now, we come to control unit. Now, as the name suggests, control unit, it is responsible for controlling the overall operations performed by the microprocessor. Now, what are the various operations which are need to be controlled by the microprocessor? Now, the microprocessor mainly performs 4 operations, that is either it reads the data from memory, or it writes the data into memory, or it reads the data from a IO device, or it sends the data to a IO device. Now, to perform all these operations, microprocessor needs some control signals. Now, to write the data in the memory, microprocessor needs the control signal, that is memory read. Similarly, to read the data from memory, microprocessor needs memory read signal. Again, to write the data to a IO, it needs a control signal, that is IO write, and similarly to read the data from IO, it needs a control signal, that is IO read. So, this control unit is responsible for generating all these control signals, that is memory read, memory write, IO read and IO write. Now, next we come to the registers, which is again an important part of a microprocessor. As we all know, the microprocessor ultimately performs certain operation over the operands. Now, operands are obviously the data on which operations are performed. Now, to perform the operation on the operands, microprocessor needs to transfer these operands into the processor first. Now, there are certain locations where these operands are stored temporarily. These locations are the registers. For different microprocessors, they have their own internal registers. Now we come to some important terms related to microprocessor. These terms are word length, opcode, operand and mnemonics. Now first of all, we discuss the word length. The number of bits that a processor can process in parallel at a time is the word length of the processor. It is equal to the size of data bus of a microprocessor. For 8085 it is 8 bit, for 8086 it is 16 bit and so on. Now this word length is the one of the most important feature for a microprocessor. It actually defines the efficiency of a processor. Suppose we say that 8085 is a 8 bit microprocessor, means its word length is of 8 bit. It means it can accept 8 bit data in parallel at a time for processing. Obviously, as the word length of the processor increases, its speed of execution will also increase. Now the next term is the opcode. This opcode is an short form used for operation code. As we all know, the microprocessor works on assembly language, or we can say the programming is done using the assembly language, but this assembly language is for user interface only. Ultimately, the processor can run the instructions only when they are in the binary form. So, to define the instruction to the microprocessor, we go for a opcode. Each instruction has its own unique opcode, that is a operation code, and the opcode is nothing but a hex code, which is again a unique for a instruction. After that, we come to the next term, that is an operand. This operand is nothing but the data on which the operation is to be performed. Obviously, to perform any operation, microprocessor needs the data or a operand, and this operand is again provided by the user in the memory, and it is fetched from the memory to the microprocessor. Now we come to the term mnemonics. This mnemonics is a Greek word which means the instructions which defines their operation itself. Actually, the assembly language is a collection of mnemonics. Each and every microprocessor has its own set of mnemonics which are used for the assembly language programming of that microprocessor. Like 8085 has its own mnemonic set, 8086 has its own, and so on. This is the main reason why the processor programming is not going too high level. The reason behind is that each processor has its own mnemonic set. So, we can say that microprocessor is a machine dependent, or we can say it has a assembly language dependency. As I know the processor programming for 8085, but I am not comfortable with the assembly programming of 8086, or I am not familiar with the mnemonic set of the 8086. So, I cannot go for the programming of 8086 unless and until I have the knowledge of the mnemonics of 8086. Now we come to another important basic term of microprocessor, that is the bus system of a microprocessor. For each and every microprocessor, there is an specific bus system. Now first of all, let us discuss what is bus. Now buses are the set of lines which are used by the microprocessor for communication with the peripherals or the memory. Each and every microprocessor has its own bus system, and it is an important component for a microprocessor. For a processor, there are three basic types of buses. They are address bus, data bus and control bus. Now let us discuss first the address bus. Its main features are, it is unidirectional in nature. For 8086 microprocessor, the address bus is of 20 bit. Using this address bus, 8086 microprocessor can access 1 MB of memory externally. The hexadecimal address range for this is from 00000H to FFFFH. The 8086 microprocessor uses segmented memory. The segments are logical segments. Now, let us discuss about this address bus. As we all know, whenever a data or a code is to be fetched from the memory, the first important thing is the address of the memory from where the data or the opcode or the byte is to be fetched. Now, this address is accessed with the help of address bus. The microprocessor puts the address on the address bus, and as this address bus is unidirectional, that is, the address is transferred from microprocessor towards the memory side. Once the address is decoded, now the microprocessor bus system are ready for further processing. So, once the address is decoded or the address is identified, now the next bus come into the role. Now, this next bus is the data bus. This data bus is solely responsible for transfer of data between the microprocessor and the memory or the microprocessor and the IO. This data bus is bidirectional in nature. For 8086 microprocessor, the data bus is of 16 bit. Using this data bus, 8086 can transfer data from processor to memory or from memory to processor. The data can be transferred from processor to input output or from input output to processor. The important thing is that each location in the memory can store 8 bit data only. Now, let us discuss something about this data bus. This data bus is solely responsible for carrying the information from memory or IO into the processor. As we all know, when the processing starts, the first job for microprocessor is to fetch the opcode of the instruction into the processor for decoding and further processing. Now, this fetching of opcode from memory is done with the help of this data bus only. Similarly, the operands or the data are fetched from memory or IO into the microprocessor with the help of this data bus only. Once the operand and data and codes are being fetched and being executed, now the result which is available in the microprocessor is transferred back to the memory or IO with the help of this data bus only. So, the next role after the address bus is of this data bus. Then next we come to again an important bus of a microprocessor, that is the control bus. These are actually the group of lines used to generate different control signals. The different control signals required in the microprocessor are memory read control signal, memory write control signal, IO read control signal and IO write control signal. Now, let us have a discussion about this control bus. As we all know, the microprocessor mainly performs 4 different tasks, that is either reading the data from memory or the writing data in the memory or receiving the data from IO or sending data to IO. Now, all these operations are governed by the control bus by simply generating the different control signals as and when required. So, this is the discussion about the address bus, the data bus and the control bus of a microprocessor. Now, next we come to an important topic, that is the flag register. Now, first we discuss what is the flag register. A flag is a flip flop which indicates some condition produced by the execution of an instruction or controls certain operations of the execution unit of the microprocessor. The 8086 flag register contains 9 flags which we will discuss now. Now, the flag register of 8086 microprocessor is of 16 bit. This flag register has 9 flags in it and remaining are the don't care conditions or undefined conditions. The overall flag register of 8086 is divided into two parts. One is the conditional flag register and another is the control flag register. The conditional flag register includes sign flag, zero flag, auxiliary carry flag, parity flag, carry flag and the overflow flag. Now, out of these flag, the overflow lies in the higher byte of the flag register and remaining all lies in the lower part or the lower byte of the flag register. We will discuss all these flags one by one. Actually, a flag is nothing but a SR flip flop which is set or reset according to the result of the arithmetic or the logical operation performed by the ALU in the microprocessor. Now, we will discuss the flags one by one for their set condition and for their reset condition. Now, let us start with the carry flag. As the name suggests, carry, we all know a carry is generated whenever we perform an operation and the result is out with the maximum limit. So, in case of addition, this flag is set if there is a carry out of the MSB, that is most significant bit position. The carry flag also serves as a borrow flag for the subtraction. In case of subtraction, it is set when borrow is needed. So, we can say the carry flag is acting as a carry flag as well as the borrow flag. Obviously, it is working as a carry flag for the addition operation and it is working as a borrow flag for the subtraction operation. Then the next flag is the parity flag. Now, the parity, it is nothing but the number of ones in a binary pattern. Here, it is set to 1 if result of the byte operation or the lower byte of the word operation contains an even number of ones, otherwise it is 0. Now, it means like if we have performed an arithmetic or logical operation say for 16 bit, as 8086 can perform the operation on the operand which is of 8 bit or it can perform the operation on an operand which is of 16 bit. Now, we are taking the case for a 16 bit. For a 16 bit operation, the result is such that the lower byte of the result contains even number of ones. Then definitely the parity flag of 8086 microprocessor will set to 1 due to this even number of ones in the lower byte of the result. Now, next flag is the auxiliary carry flag. Now, this flag is set if there is a carry from lower nibble side to higher nibble side. This flag is used for BCD operation and it is not available for the programmer use. So, this flag is used by the microprocessor internally only. When we perform an arithmetic or logical operation and a carry is transferred from lower nibble side to higher nibble side, then the auxiliary carry flag will be set. And if there is no carry from D3 to D3 position, then auxiliary carry will be reset or 0. Now, the next flag is the 0 flag. The 0 flag sets if the result of operation in ALU is 0 and flag resets if the result is non-zero. The 0 flag also set if certain register contents become 0 following an increment or decrement operation of that register. Now, in simple language we can say that 0 flag is set to 1 when all the bits of a result which is obtained by some arithmetic or logical operation are 0. Means all the bits are 0, then 0 flag is set to 1, and if the result is non-zero value, then 0 flag is reset. Then next we come to the sign flag. After the execution of arithmetic or logical operation, if the MSB of the result is 1, the sign bit is set. Sign bit 1 indicates that the result is negative, otherwise it is positive. Now, the important thing for the sign flag is that it is considered when we go for sign magnitude arithmetic. Otherwise, if we are working on hexadecimal number system, we need not to bother about this sign flag. But if we are working on sign magnitude arithmetic, then the most significant bit is a sign bit. If the result for the operation is such that MSB is 1, then number will be treated as a negative number, and if the most significant bit of the result is 0, then the number will be treated as a positive number. Next we come to overflow flag. This flag is set if the result of is out of range. For addition, this flag is set when there is a carry into the MSB and no carry out of the MSB or vice versa. Similarly, for subtraction, it is set when the MSB needs a borrow and there is no borrow from MSB or vice versa. Now, the question arises that what is the difference between a carry flag and a overflow flag. So, let us be clear. Carry flag, we say that when a carry is generated from most significant bit position, then carry flag is set to 1. It is simply saying that a carry from MSB means it is the part of the result, but the overflow suggests that your result has exceed the maximum capacity, that is the storage capacity where the result will be stored. Overflow never suggests that it is the part of result, it is just suggesting that your result has exceed the maximum storage capacity. So, if you are working on a 8-bit operand and your result has exceed 7-bit, because the most significant bit is the sign bit. So, if your result has exceed the 7-bit, then overflow flag will be set. Similarly, if you are working on 16-bit and your result has exceed 15-bit, then again the overflow flag is set. Now, next we come to trap flag. This is used for moving the microprocessor 8086 into single step mode. Now, when a trap flag is set, it means after the execution of instruction, a interrupt will be generated. Again, when this interrupt service is complete, microprocessor again goes for the next instruction execution. We can say when trap flag is set, microprocessor works in the single step mode. It will execute an instruction, then it will service the interrupt, then it will again execute the instruction, and so on. Then next we come to interrupt enable flag. Now, when this flag is set to 1, the microprocessor will provide the service to the interrupts from external device, and if this flag is set to 0, microprocessor will not entertain any interrupt externally. Actually, this trap flag, interrupt flag, these are the part of the control flag register. That means the programmer or the user can set these flag as 1 or reset these flags can 0. Now, we come to the direction flag. This flag is used by some instructions to process the data chain or the data string. When this flag is set to 0, the processing is done in the forward direction, that is lower address towards the higher address, and when this flag is set to 1, the processing is done in the backward direction, that is from higher address towards the lower address. Now, basically this direction flag is used in 8086 microprocessor when we have to perform certain operations on the string. A string is the collection of similar type of data stored in the consecutive memory locations. Now, a string can be accessed or processed bidirectionally. Either a string can be processed from lower address, that is starting from lower address and moving towards the higher address, and another approach is starting from higher address and then moving towards the lower address. Now, if the direction flag is set to 0, the processing is done in the forward direction, that is, we will start with the lower address and then we will move towards the higher address. Similarly, if the direction flag is set to 1, then the string is processed in the backward direction, that is, we will start from the higher address and then we will move towards the lower address. Then we come to the overflow flag. This overflow flag is set to 1 when there is a signed overflow. Now, what is this signed overflow? As we have already discussed, signed overflow means when we are performing the 8-bit operation and result is greater than 7-bit, and if we are performing 16-bit operation, then result is greater than 15-bit. So, to summarize, today we have discussed some fundamentals of microprocessor, which included the definition of the microprocessor, what are the buses which are available in the microprocessor, then what are the flag registers of the microprocessor, and we discussed about the flag register of 8086 microprocessor, in which we discussed the various flags. I hope you all have enjoyed this short lecture on the fundamentals of the microprocessor and its various parts. Thank you.